So if you're watching this video, you've probably seen some version of this meme, a chicken being slapped at a high speed and ultimately becoming a cooked chicken. So let's take a quick peek at the physics behind this and figure out how to calculate this out for ourselves. So this whole cooking a chicken with a single slap thing originally started on Reddit when someone asked, if kinetic energy is converted into thermal energy, how hard do I have to slap a chicken to cook it? And of course, a friendly neighborhood physics major decided to throw together some numbers and come up with a quick thing. And they got a result of about 1,665.65 meters per second, or roughly 3,725.95 miles per hour. So there's an important assumption present here, and that's that the kinetic energy of the slap is being directly transferred into the chicken. No energy is theoretically being lost in the transfer. So there's no sound, because if you slap something, part of the energy is going away in sound waves. There's no deformation of the chicken, so when you slap it, it's not breaking or bending or anything. Also, the chicken itself isn't moving, it's staying perfectly still, so none of that energy is being lost that way, etc., etc. So the kinetic energy is directly transferring to thermal energy. So if we want to derive this equation, then we just set up a kinetic energy equation and a thermal energy equation. So the kinetic energy equals 1/2 times the mass of the hand times the velocity of the hand squared. And the thermal energy equals the mass of the chicken times the specific heat of the chicken times the change in temperature of the chicken. Then the important assumption we made earlier is that these two values are directly equal to each other. So the kinetic energy equals thermal energy. And then we plug in the other sides. So 1/2 mass of the hand times velocity of the hand squared equals mass of the chicken times specific heat of the chicken times the change in temperature of the chicken. We divide both sides by the mass of the hand, multiply both sides by 2, and then take the square root of both sides. And ultimately, we get the velocity of the hand equals the square root of 2 times the mass of the chicken times the specific heat of the chicken times the change in temperature of the chicken divided by the mass of the hand. And of course, the best part of any physics problem is plugging in all the values. So we can solve for the velocity of the one slap to cook the chicken by plugging in that one human hand weighs roughly 0.4 kilograms. The average rotisserie chicken weighs about 2 pounds or 0.91 kilograms. The specific heat capacity of a chicken is 3,210 joules per kilogram degrees Celsius, and it should be considered cooked when it reaches an internal temperature of 180 degrees Fahrenheit or 82.2 degrees Celsius. And the 82.2 degrees Celsius is also going to be the delta T because we're starting at a value of 0 degrees Celsius since it's a frozen chicken that we're starting with. So we plug all those into our previous equation that we just derived. We end up with velocity equaling 1,095.7 meters per second. So this is a good deal less than our Reddit value, and the first question, of course, is why is it less? So the original Reddit answer assumes that the chicken finishes cooking at an internal temperature of 400 degrees Celsius rather than the 82.2 degrees Celsius given by allrecipes.com. This change is probably meant to offset a lot of the assumptions of the problem, mainly the idea that the slap is perfectly dissipating energy through the chicken. Because again, if you're slapping it, it's not going to perfectly, evenly spread out all of that slapped energy in real life. So I guess they're trying to assume something a little bit higher to offset that. But at the same time, 400 degrees Celsius, if your chicken was at that temperature internally, it would be like charcoal practically. It's not going to be what we consider a cooked chicken. So at the same time, that's perhaps a little bit high of an assumption. So we could actually transfer what we just learned to a different scenario just to kind of test the theory behind it. So as a sample scenario, how fast would you have to slap a small puddle consisting of 2 kilograms of water at room temperature to boil it? And of course, instead of the mass of the chicken, we're now using the mass of water, which is 2 kilograms. There's going to be a different specific heat, which you can Google, and the delta T from room temperature water to boiling point of water is of course different. But you guys could give that a quick Google if you'd like. Figure out this quick sample problem. Comment below, I can give you some feedback. If you guys have feedback for the video, I'd appreciate it. Some new ideas, certainly. Shoot your shot, and thank you for watching.